Now let's talk about bounded sequence. A sequence is bounded above if you can find a fixed value like m such that the terms of the sequence are less than or equal to that fixed value. A sequence is bounded below if you can find a fixed value like m such that all terms of the sequence are more than fixed that value. So you say that a sequence is bounded if it's bounded above and also below. Let's go over some examples. For example, consider the following sequence. The sequence like an, which is equal to 1 minus 1 over n. I'm going to analyze this sequence. So the terms of the sequence, if n is equal to 1, you get 1 minus 1 or 0. If n is equal to 2, you get 1 minus a half, which is a half. If n is equal to 3, 1 minus a third, which is 2/3, and so on. Remember, if you could take the derivative of this function, 1 minus 1 over x, f prime of x is negative. So here you have a 0 minus the derivative of 1 is 0 times x minus the derivative of x, which is 1. So you get another negative 1, negative 1 divided by x squared, which is 1 over x squared. So this is positive. So you expect the graph to be increasing. So this is positive. So an, or in this case, your f of x is the same. Behavior is increasing. Okay, but how increasing is that? This function is bounded by 0 and also 1. The limit of 1 minus 1 over n as n approaches infinity is 1 minus 0, which is 1. The function is increasing and the maximum value it takes is 1. 1 minus 1 over n is bounded between 0 and 1. So it has a lower bound and it also has upper bound. So it is bounded. We can take a look at Desmos. Always verify these. So let's go back to Desmos. Here I'm going to graph this function 1 minus 1 over x. Remember that all of these functions are connected together. Since we are working on sequences, we only look at the positive part of the function, and it starts at 1. When I plug in 1, I'm not using fractional behavior here. So the function behaves like this. So the function has a graph starting from 1 to the right-hand side, 1 to infinity. And as you can see, the graph is increasing, but it's not a sharp increase. It stays around 1. The upper bound is y equals to 1. And the lower bound is y equal to 0. So you have a lower bound, which is a constant function. You have upper bound, which is another constant function. And that's how we see the behavior of this function, which is represented in red. Let's take a look at another sequence. So for this sequence, Bn is equal to 1 plus 1 over n. So as usual, we can represent the function in x and analyze this. F prime of x is negative 1 over x squared, which is negative. So we expect Bn to be decreasing. Very good. If I take the limit of 1 plus 1 over n, as n approaches infinity, it is 1 plus 0, which is 1. We expect this guy to approach 1 as well. If you write down the terms of this sequence, if n is equal to 1, you get 1 plus 1, which is 2. If n is equal to 2, you get 1 plus a half, which is 3 halves, and so on. This function or this sequence is bounded between 1 and 2. The minimum value it has is going to be 1, and the maximum value it has is 2. We can look at the graph of this function and see what's happening here. So again, if you use Desmos, this guy shows X. It doesn't give you the sequence, but we can analyze this by looking at the graph of the function. So take a look. So again, you're not looking at the whole thing. When X is equal to 1, when N is equal to 1, you have the maximal value, which is 2. You look at the function from this point to the right. So here, I'm just going to move this a little bit further here. So we have better visualization of the behavior of this function. Very good. So this is the graph of the sequence in continuous form. But remember that for a sequence, you need to have dots. Is continuous. So again, take a look. Your minimum value of sequence is 1. The maximum value it takes is 2. So it has lower bound and upper bound. The lower bound, y equals to 1. And the upper bound, y equals to. Again, I looked at the very first term. I found the limit. I analyzed the behavior by taking the derivative. And this is the conclusion. The lower bound is 1. And the upper bound is 2. So on the exam, if I ask you to write example of bounded sequence, which is increasing, you can represent this sequence. If I ask you to give me an example of a bounded decreasing sequence, you can use this example.